Okay, today we are talking about finding experimental probability. Okay, so experimental probability is the likelihood that something's going to happen, and it's based on experimental data. So you collect data from doing experiments, and then from that information you figure out the probability of something happening. So for example, if we look in this text, and move it over so you can see it. At this problem here, we have, it says the scientist Gregor Mendel crossbred green seed plants and yellow seed plants out of 8,023 crosses. So he crossed plants 8,023 times, so that's our total. 6,022 plants had yellow seeds and 2,001 had green seeds. And we need to find a probability that a plant had green seeds. So to do that, what we would do is we take the probability of an event, that's how we write it, probability of an event for experimental probability is going to equal the number of times event occurs, so whatever you're looking for, and we're going to divide that by the total number of trials. So if we are looking for, in example 1, the probability that a plant had green seeds, then what we are looking for is we are looking for the probability of green seeds. So we would write it like that. And to calculate that, we would take the number of times that occurred. So 2,001 times he got green seeds. Oops. 2,001 times he got green seeds out of the total number of trials. Well, the total is this 8,023. And then to make it easier to look at, because that's obviously a big fraction, we're actually going to divide and change this to a decimal. Okay, with big numbers like this, we're usually going to change the probability to a decimal. So 2,001 divided by 8,023 is, we're going to go to 3 decimal places. So the probability equals 0.249, which is about 25% of the time. Okay, you can express probability as a fraction, as a decimal, or as a percentage. If we wanted to do it as a percentage, it'd be just like calculating your grade. It'd be like saying you got a 2,001 out of 8,023 total. You would do top divided by bottom and then multiply that decimal by 100. So you see it's a 24.9% chance of getting green, which we could round to 25%. Any of these answers would be acceptable. The fraction, this or this. The fraction is probably the least helpful because we can't really picture that in our heads as well. You could round them both and make it about 2/8 or 1/4. But with these big numbers, either rounding the fraction or using the decimal percentage would be our best ways to answer. So let's try another experimental probability. At the bottom of the page of this book here, it says, use the table at the left, so right here, find the experimental probability of getting heads. Okay, so again, to find the probability, we need to do the total number of times the event you want occurs divided by the total number of trials. So we're trying to get heads. So first thing is we're going to write it as the probability of getting heads, like that. And that's going to equal, well, how many times did heads occur? There were 5, 6, 7, 8 heads. And then we need to do the total number of trials on the bottom. So the total number of trials is going to be all of these together. So 5, 10, 15, 20. So 8 over 20 is our experimental probability. If we want to leave it as a fraction, we would need to simplify it down. So we can get it down to, you can divide those both by 4. So we could call it 2/5. Or we could do it as a decimal, or 0.4, or 40%. Any of these 3 ways would be acceptable for writing our answer. So you got heads in this experiment. You got heads about 40% of the time. Whoops. All right, let's try another one. Okay, let's look up here. We're finding each experimental probability. So you planted 250 seeds from a bag. All the seeds grew, and when they grew, there were 68 marigolds, 94 alyssum, 8 poppies, and the rest are zinnias. So what I want you to do is pause the video, and I want you to calculate the probability based on this experiment, your probability of getting a marigold from this bag of seeds. So go ahead, pause the video and calculate that, and then restart the video to check your work. Okay, so probability of marigold. So first off, our total is 250. That's the total number of seeds, so that should go on the bottom of my ratio, my fraction. And then the marigolds, there were 68 marigolds. So you should have started out with the fraction 68 250ths. Okay, so we are going to divide those, and it is a 0.272 probability. Or you could say it's about 27% probability that a seed from that bag is a marigold. So that should have been your answer there. Or you could have been 34 125ths, but that's not a real great way to tell a probability because it's too big, it's too hard to look at. So we really want to focus on using the decimals and the percentages. So that is how you calculate experimental probability.